Alright, this is also solving for enthalpy, but this time we're using problem 3 to show an example. So again, we always have our balanced equation, and we have our information here, which include, and the first one showed 2, this one has 3, and it always has these. Okay. So starting off, I always write what they are down here so I can always edit them easier. And then H2O becomes an H2O in this reaction, I guess. All right, so back in first step, you make sure everything's on the left is on the left and everything on the right is on the right. So for this, H2O is on the left, which is a true statement. H2O is on the left. Carbon is on the left, which is true. But this is actually a really important step. Since there's 2 carbons here, and there's only 1 carbon here, this carbon doesn't count. But because there's only 1 carbon or 2 carbons here and 1 carbon in our final thing, we actually have to multiply this by 0.5. Which get rid of, when we rewrite this, we'll get rid of the 2. So right now, while rewriting it, actually, we'll do that first. It'll be just carbon plus half of O2 goes to, and then just 1 CO, produces 1 CO. So that'll be our new thing. And actually, don't forget, this step for this. So we multiply this by 0.5 because that's what we did on here. All right. So then we continue the next step. We have our 1 carbon left, and that produces CO at the end, which we do have. H2 at the end, which we actually don't have. Oh, hold on, let me look at this. No, okay, yeah, we don't. So over here again, this has 1, and there's no other H that can really do anything with it. So for this, we'll also have to multiply this by 0.5, which would then change this into, oh, actually this is a double step because H2 is on the right side. So you would multiply this by negative 0.5. So in here, you multiply this by negative 0.5. Okay. So once you multiply this, you get a swapped reaction. So it would just be 1 H2O produces 1 H2, and if you can guess it, if there's 1 O2 here, or 0.5 O2, I guess, but there's no O2 in our final equation, this has probably become 0.5 O2, so they can cancel each other at the end. So it'd just be 1/2 O2. Okay. We no longer need this. So we bring this over. And H2 is now on the right side. Therefore, everything is looking handy. So we start canceling out stuff. First that has to go is the half oxygen. That's the same. One of the H2Os gets canceled. There's 3 different ones. Not everything can go with each other. Which just leaves carbon and high H2O. There's an invisible plus here. Carbon H2O produces CO and H2, which is right. So since we got all that, our new values would be enthalpy equals -111 kilojoules. Second one would be multiplying that and making it positive. So it would be positive 242 because you're halving it. And the last one stays the same, just 44 kilojoules. And when we calculate this, it would just be 242 minus 111 plus 44, which equals a H final of roughly about positive 175 kilojoules.